Welcome to the Platform Engineering Playbook podcast, where everything you hear is built, reviewed, and improved by AI, by me, and by you, the listener. This show keeps me, and hopefully you, up to speed on the latest in platform engineering, SRE, DevOps, and production engineering. It's a living experiment in how AI can help us track, explain, and discuss the fast-moving world of infrastructure. Every episode is open source. If you've got something to add, correct, or challenge, head to platform-engineering-playbook.com. You'll find all the content and a link to the GitHub repo. Open a pull request, join the conversation, and make the playbook smarter. Let's get into it.
Welcome to Episode 3 of Kubernetes Production Mastery. In the last episode, we mastered resource management, requests, limits, and quality of service classes. Before we continue, try to recall what happens when a pod exceeds its memory limit. That's right, it gets OOM killed with exit code 137. But here's what we didn't discuss. How does Kubernetes decide when to restart that pod? Or more importantly, how does it know if your application is actually healthy after it restarts? That's where today's topic comes in: health checks and probes. By the end of this lesson, you'll be able to configure the 3 types of Kubernetes probes with production-appropriate thresholds, diagnose why pods are stuck in CrashLoopBackOff or marked not ready, and design health endpoints that actually validate application health, not just process existence. Let me tell you about last week at a major fintech company. They had a 47-minute outage that cost them $2.3 million in SLA penalties. The root cause? A misconfigured liveness probe. The probe was checking if the process existed, not if it could actually process transactions. The application was completely deadlocked, threads frozen, unable to handle a single request. But Kubernetes thought everything was fine because the process was still running. This is the kind of mistake that seems obvious in hindsight, but happens all the time in production. Here's the thing about probes. They're Kubernetes asking your application 3 fundamentally different questions. And if you give the wrong answer to any of them, you're going to have a bad time. The startup probe asks, "Are you done initializing?" This protects slow starting containers. Think about that Java application with a 2-minute boot time while it loads Spring context, warms up connection pools, and builds its cache. The readiness probe asks, "Can you handle traffic right now?" This controls whether your pod receives requests from the service. It's your circuit breaker. The liveness probe asks, "Are you still alive or do you need a restart?" This is the nuclear option. When this fails, Kubernetes kills your container and starts fresh. Now you might be thinking, why 3 different probes? Can't we just have one health check? Here's why that doesn't work. Imagine your application starts up. It needs to connect to a database, warm up its cache, maybe download some configuration. That takes time. If your liveness probe kicks in after 30 seconds, but your app needs 90 seconds to start, you've created a restart loop. The app never gets a chance to become healthy. That's what the startup probe prevents. It gives your application time to initialize before the other probes even begin checking. Once your app is running, you need to know 2 different things. First, is it healthy enough to handle traffic? That's readiness. Second, is it so broken it needs to be restarted? That's liveness. And here's the critical distinction that trips up even experienced engineers. These are not the same question. Your database might be down. Should that fail your liveness probe? Absolutely not. Your application is healthy. It's the database that's having problems. Restarting your app won't fix the database. In fact, it'll make things worse when the database comes back and suddenly has a thundering herd of restarting applications all trying to reconnect at once. But should the database being down fail your readiness probe? Yes! You can't handle traffic if you can't reach your database. You want Kubernetes to stop routing traffic to you until the database recovers? See the difference? Readiness is about capability. Liveness is about the application itself. Let's talk about how these probes actually work under the hood. You've got 3 mechanisms to choose from. HTTP GEET is the most common. Kubernetes calls your endpoint and expects a 200 to 399 status code. Anything else is a failure. Simple, right? But here's what people miss. This isn't just about returning 200 OK. This is your chance to actually validate that your application works. TCP socket is simpler. Kubernetes just tries to open a TCP connection to your specified port. If it connects, you're healthy. This is useful for databases or other TCP services that don't speak HTTP. Exec runs a command inside your container. If it exits with code 0, you're healthy. This is powerful, but be careful. You're running this command frequently, so it needs to be lightweight. Now let's talk about timing, because this is where things get really interesting. You've got 5 timing parameters to work with. Initial delay seconds tells Kubernetes when to start checking after the container starts. Period seconds is how often to check. Timeout seconds is how long to wait for a response. Success threshold is how many successes before you're considered healthy. And failure threshold is how many failures before Kubernetes takes action. Here's what actually happens when a readiness probe fails. After failure threshold consecutive failures, your pod gets marked not ready. The endpoints controller sees this and removes your pod from the service endpoints. The ingress controller updates its backend pool. No new traffic routes to your pod. Existing connections might persist depending on your setup, but you're effectively out of the load balancer. For a liveness probe failure, it's more dramatic. After failure threshold failures, the kubelet initiates a pod restart. Your container gets a sigterm signal. If it doesn't exit gracefully within the termination grace period seconds, it gets SIGKILL. Then Kubernetes starts a new container. If you have a startup probe, that runs first. Only after the startup probe succeeds do the readiness and liveness probes begin. Let me show you what this looks like in practice with a real-world example. An e-commerce API with a database dependency. For your startup probe, you want to check that everything's initialized. Application context loaded, database migrations completed, cache warmed if that's required, external service clients initialized. Here's what that looks like. Startup probe, HTTP, get path /health/startup on port 8080. No initial delay. We want to start checking immediately. Period of 10 seconds. Check every 10 seconds. Timeout of 3 seconds. If it takes longer than 3 seconds, something's wrong. Failure threshold of 30, that gives us 5 minutes maximum for startup. That's generous, but production applications with large caches or complex initialization might need it. Your readiness probe is different. This checks if you can handle traffic right now. Database connection pool has available connections, required external services reachable, no circuit breakers open, not in maintenance mode. Readiness probe, HTTP, get path /health/ready on port 8080. Again, no initial delay. As soon as the startup probe passes, we want to check readiness. Period of 5 seconds, more frequent because readiness can change quickly. Timeout of 2 seconds, success threshold of 1. As soon as you're ready once, you can handle traffic. Failure threshold of 3, but 3 failures in a row means stop sending traffic. And here's the critical one, your liveness probe. This should be shallow. I can't emphasize this enough. Your liveness probe should only check if the application itself is healthy. Not dependencies, not external services, just the app. Liveness probe, HTTP, get path /health, live on port 8080. Initial delay of 60 seconds. Let the startup and readiness probes stabilize first. Period of 10 seconds. Timeout of 5 seconds. Give it a bit more time since restart is disruptive. Failure threshold of 3. What should this liveness endpoint actually check? Application threads, not deadlocked. Event loop responsive. Memory not critically exhausted. Can perform a basic operation like returning the health status. That's it, nothing more. Now let me tell you about the 5 most common mistakes I see in production. These are the ones that cause outages. Mistake number 1. Your liveness probe checks external dependencies. Your app is healthy, but the database is down. Liveness probe fails, triggers a restart. App restarts, database is still down, probe fails again. Congratulations, you've created a restart loop that makes recovery impossible. When the database finally recovers, your app is mid-restart and can't serve traffic. The fix? Liveness should only check the application itself. Use readiness for dependencies. Mistake number 2, identical readiness and liveness probes. If they're the same, why have both? This usually means you're not thinking about their different purposes. Readiness answers, can I serve traffic? Liveness answers, am I frozen? Mistake number 3, aggressive liveness probe timing. Failure threshold of 1, period of 5 seconds, timeout of 1 second. This killed production last Tuesday at a client site. 1 slow garbage collection, 1 network hiccup, and boom, unnecessary restart. Your liveness probe just caused more problems than it solved. The fix? Be generous with liveness timing. Restarts are disruptive. You want to be really sure the application is broken before you pull that trigger. Mistake number 4, no startup probe for slow starting applications. Your Java app takes 90 seconds to start. The liveness probe kicks in after 30 seconds and kills it. The app restarts, takes 90 seconds again, gets killed after 30. Restart loop. The fix? Always use a startup probe for applications with initialization over 30 seconds. Give them time to actually start. Mistake number 5, your health check does expensive computation. The health endpoint queries the entire database, aggregates metrics, validates every connection, takes 5 seconds to respond. Gets called every 5 seconds by 3 different probes. You've just dosed yourself with your own health checks. The fix? Health checks must be lightweight. Milliseconds, not seconds. Let's talk about patterns for production. The key pattern you need to understand is shallow versus deep health checks. Shallow checks are for liveness. Is the process responsive? Basic memory check. Can I return a simple response? That's it. Deep checks are for readiness. Can I actually do my job? Validate functionality. Check dependencies. Ensure I can handle real requests. Never, and I mean never, use deep checks for liveness unless you want cascading failures across your entire system. Now, when you're debugging a crash loop backoff, here's your workflow. First, check the probe configuration with kubectl describe pod. Look for probe failure events. They'll say something like, liveness probe failed. Get http:// Test the endpoint manually from inside the pod with kubectl exec. Sometimes the endpoint works, but not on the port or path you configured. Check probe timing versus actual startup time. Your app might need 45 seconds, but your startup probe only gives it 30. Review the container logs. Sometimes the container is crashing before the probe even runs. Exit code 1 means your app errored. Exit code 137 means OOM killed. Exit code 143 means SIG-term. For NotReady pods, it's a different investigation. Check readiness probe events in the pod description. These will tell you exactly what's failing. Verify the endpoint is actually accessible from within the pod. Sometimes it's a networking issue, not a health issue. Check if dependencies are available. Is your database up? Can you reach external services? Review service endpoint registration with kubectl get endpoints. You should see your pod IP there if it's ready. All right, pause the audio and answer these questions. First, your pod keeps restarting every 2 minutes. Which probe is most likely misconfigured? Second, your application takes 3 minutes to warm its cache on startup. Which probe type should you use to protect it? Third, the database is down. Should this fail your liveness probe, readiness probe, or both? Here are the answers. First question, if your pod keeps restarting, it's the liveness probe. That's the only probe that triggers restarts. Readiness just stops traffic. Startup just delays the other probes. Second question. For an app that takes 3 minutes to warm cache, you need a startup probe. It protects slow initialization from the other probes. Set the failure threshold high enough to give it time. Third question. Database down should fail only your readiness probe. Never liveness. Liveness checking external dependencies causes cascading failures. Your app is healthy even if the database isn't. Let's bring this all together. You've learned 3 types of probes with 3 distinct purposes. Startup for initialization, readiness for traffic control, liveness for restart decisions. Remember that liveness probes are nuclear options. Be conservative with timing and checks. An unnecessary restart is worse than delayed detection. Never check external dependencies in liveness probes. That's what readiness is for. This is probably the most important lesson today. Health endpoints must be lightweight. They're called frequently, every few seconds by multiple probes. If your health check takes a second to respond, you're doing it wrong. Failed probes are the number 3 cause of production Kubernetes outages, right after resource limits and network policies. This connects directly to the production mindset we discussed in episode 1. Health checks are your first line of defense. They work with the resource limits from episode 2. A pod that's OOM killed needs proper health checks to recover correctly. Remember those 5 failure patterns from episode 1? Improper health checks contribute to 3 of them: cascade failures, thundering herd, and cold start problems. Next time, we're exploring Kubernetes networking and service discovery. You'll learn why pods can't reach each other and how to fix it. The difference between cluster IP, node port, and load balancer services. And how DNS actually works in Kubernetes. Spoiler alert, it's not magic, but it can feel like dark magic when it breaks. This builds directly on today's health checks. After all, what good is a healthy pod if traffic can't reach it? See you in the next lesson.
That's it for this episode of the Platform Engineering Playbook podcast. Every topic, transcript, and summary you just heard lives out in the open at platform-engineering-playbook.com, where anyone can suggest updates or add insights through GitHub. If you've got thoughts, fixes, or new ideas, open a PR. And if you enjoyed the episode, rate us on your favorite podcast platform. We're always shooting for 5 stars. While you're there, give the project a star on GitHub. It helps others find and contribute to the Platform Engineering Playbook. This podcast is generated by AI, reviewed by AI, me and you, a community of engineers keeping our craft sharp. Thanks for listening, and see you next time inside the Platform Engineering Playbook.